Hello everyone, welcome to today's class. We are going to look at number base. Number base is counting number in a particular base. In normal counting, we make use of base 10, but we are now going to make use of different bases, starting from base 2 to other base up to base 16. Now, we are going to look at all the things that we are supposed to know in number base. So I'm going to highlight the things that we are to learn in number base. So these are the subtopics we are going to handle on number base. So we are going to start from conversion from base 2 to base 10. So when we are done with that, we now move from base 10 to base 2. Remember, these also include the fractional or decimal numbers of these bases. What am I trying to say? We are going to also look at the fractional form of base 2 to base 10, and we're also going to look at the fractional form of base 10 to base 2. Then after that, when we have gained knowledge from here, we are going to come here to look at conversion from other bases to base 10, vice versa. Now, what does that mean is that from the knowledge we have gathered from here, it will be easier for us to move from base 8 to base 2, or base 8 to base 10, or base, all those other conversion of bases. So we are going to handle it here. Then after that, we now move to hexadecimal. Okay, hexadecimal is not going to be difficult at all, because from doing all this here, doing hexadecimal will not be very simple. Then from there, we now move to arithmetic operation in number base, where we add, we multiply, we divide, and we subtract. Then from there, we now move to problems that will lead us to algebraic fraction. There are some number-based problems that will give you linear equation, while other number-based problem can also give you quadratic equation. So we are going to start from conversion of numbers in base 2 to base 10. This is where we are going to start our class today. From conversion of numbers in base 2, of course, that's what we call binary numbers, to base 10. We are going to first of all look at whole numbers when there's no decimal point. So that's what we are going to first of all look at. So let us take example. Convert the following to base 10. Number 1, 1011 base 2. So when we are asked to convert a problem like this, what are we going to do? It's a very simple way. Solution. Now, I will repeat my numbers, then I will index the number. Okay? I will index the number. Now, what do we mean by indexing the number? Now, let me take you back to base 10. Numbers that we know. We know that 1, 2, 5 in base 10 is the same thing with 100 plus 20 plus 5. Okay, remember this is base 10. So this one is going to give us 10 times 10 plus 2 times 10 plus 5 times 1. Okay, now this thing here is the same thing with 1 times 10 raised to power 2 plus 2 times 10 raised to power 1. Of course, 1 here represents 5 times 10 raised to power 0. So if you now look at what have happened here, we still have our 1, we still have our 2, and we still have our 5. Okay, so what have changed? We have put index in the base according to the base, because this base 10, that's why we have 2 here. So this one will have 10 raised to power 2, while this one will have 10 raised to power 1, while this one will have 10 raised to power 0. So that is what we normally do whenever we are converting to base 10. You multiply by the base and put the index of the number. Okay? You multiply by the base and put the index. So when you do the same thing that I have done here in this particular question, this is going to give me 1011 base 2. When I put my index, the first number here will have 0. The second number here will have 1. The third number here will have 2. And the fourth number here will have 3. Okay? Because we normally index from 0. So the first number is going to take 0, 1, 2, and 3. Now you expand it. Okay? So the way I have expanded, this is the expansion. This one here is our expansion. Okay, so what we're showing here is that we are trying to show that this will give you this. So I don't need to do all this one now. So expanding this one, I'm going to have 1 times the base. Remember, in this case, the base is 10. So the base here is what? 2. Okay, then with the index 3. So I'll put it in brackets. Putting it in brackets always help us not to make mistake. So plus the next number 0 times 2 raised to power 2 plus the next number 1 times 2 raised to power 1. The next number 1 times 2 raised to power 0. Okay, so you need to find the value of each of these. So that will give us 1 times 2 raised to power 3 will give us 8 plus 0 times 4. This will all, anytime you have a number 0, you can easily cancel it out because 0 times any number will definitely give you what? 0. So let's cancel that one out. Plus, this one will give you 1 times 2 plus any number raised to power 0 will give you 1. So we have 1 times 1. So this will give you 8 plus, of course, this one is 0. You can decide to write it, you can decide to skip it. This one will give you 2. This one will give you 1. So what we have here is 11 base 10. Remember, you can write base 10 or you can just write 11. It's only in base 10 that you can decide to write without the base. In every other basis, you must indicate the base of the number. Okay, so let us look at one more example. I'll first of all write my number and index it starting from 0. So that will give me 0. Expanding this with the way we did in example 1, that will give us 1 times 2 raised to power 6 plus 1 times 2 raised to power 5 plus 1 times 2 raised to power 4 plus 0 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. Okay, so in each of the brackets we have, we are going to simplify and get a single number. Okay, remember what we did here. Whenever you multiply by 0, that will give you 0. So this one can cancel out. So I'll have 2 raised to power 6 will give us 64. So I have 1 times 64 plus 1 times 32 plus 1 times 16 plus this is 0. So we'll move to this. 1 times 4 plus 1 times 2 plus 1 times 1. Okay, so we have to multiply each of the brackets, get our value, then we add. So that will give us 64 plus 32 plus 16 plus 4 plus 2, and plus 1. So when you add all these, what are you going to have? 119. So you can decide to write your base 10. You can also decide not to write your base 10. Okay? So that's the two examples we are going to solve on this. Anytime you have a whole number means that it does not have any decimal point. This is the simple way of getting your values. Okay? Remember, when you have your calculator with you, you can skip some of the steps. From here, you can simplify this bracket here to get this. You can simplify this to get this. You can simplify this to get this, just like that. Okay? So let us move to when we have a fractional numbers. We are going to start with whole numbers, just the same way we did in base 2 to base 10. So we are going to focus on whole numbers, probably solve two examples, then we'll now look at decimal numbers. So let's take an example. Convert the following to base 2. Convert the following to base 2. So let's take number 1, 7 2, okay, base 10. Now, how do we convert? In mathematics, most times, there are always a lot of methods to use to do a particular thing. But what I always advise students is that they should learn a method and stick to it. Practice it, get used to it, so that anytime you have a problem on that particular topic, you can always use that method that you've learned and solve your problem. Then you can as well, move to other ways of doing that so that you can broaden your knowledge on that particular subtopic. I'm going to use a particular method on this, which is, we call it successive division, okay, or terminating division. Why do we call it terminating division? Because we keep dividing this number using the base till we exhaust the number, till we get 0. That's the meaning of exhausting the number. So you keep dividing till you get 0. But as you are dividing, you will be writing out whatever that is remaining. You need to be writing them out because that is actually your answer. So let us see how this one will give us. 7 2. We keep dividing by 2. So using 2 to divide 72, that will give us 36. Will anything be remaining? No. Remainder 0. Using 2 to divide 36, that will give us 18. Will anything be remaining? No. That's remainder 0. We divide again, that will give us 9, remainder 0. We divide again, that will give us 4, remainder 1. I want to say something here. Some students, when they divide, for example, when you divide 2, using 2 to divide 9, you get 4.5. When you use 2 to divide 9, yes, it's going to give you 4.5, but that is not what we are using here. We are asking you, when you keep dividing, when you keep bringing out 2 from 9, how many numbers will you get? You get 4 of 2s. Then you now have a remainder of 1. Though that one is what is being translated here if you are talking about decimal, but we're not trying to put it in decimal. Okay, so 2 again, you will now have 2, remainder 0. 2 here, you have 1, remainder 0. This is another place I noticed that some of my students make mistake, because when they reach here, some of them will stop here. No, I said this is terminating division. You keep dividing till you exhaust the number. 1 will not even have to remain. So we need to finish it up. So when you use 2 to go in 1, it cannot divide. So we have what? 0, remainder 1. Okay, so the last number is always having zero remainder, that particular number. Okay, now when you are done, you take it from the down. When you take it from the down, your answer will not give you 1 0 0 1 0 0 0 in base 2. Remember, in other bases, you must put the base. That is how we are going to solve problem in base 10 to base 2. So let us look at second example before moving to fractional numbers. So the same way, 133 in base 10, we are converting it to base 2. The same way, you keep dividing till you exhaust the number. So when you use 2 here, you are going to have 6 remainder, put 1 here, 6 again, remainder 1. So it will give you 66 remainder 1. Now when you go with another 2 here, you have 33 remainder 0. So 2 again will give you what? 16 remainder 1. 2 in 16 will give you 8 remainder 0. 2 in 8 will give you 4 remainder 0. 2 in 4 will give you 2 remainder 0. 2 in 2 will give you 1 remainder 0. 2 in 1 will give you 0 remainder 1. So you can see it's the same way, the same process. So you use 2 to divide this. When you use 2 to divide this, you're going to have 66 and 1 will be remaining because 2 times 66 will give you 132. Okay, so 1 will be remaining. Then when you use 2 to divide 66, you have 33, nothing will be remaining. When you use 2 to divide 33, you have 16 because 16 times 2 will give you 32, so you have 1 remaining. When you divide 16 by 2, you have 8, nothing will be remaining. 8 divided by 2, 4, nothing will be remaining. 4 divided by 2, 2, nothing will be remaining. 2 divided by 2, 1, nothing will be remaining. 2 divided by 1, so 1 divided by 2, it cannot go, so that's 0, remainder 1. So you take it from the down, so that will give you 1 0 0 0 0 1 0 1 in base 2. So as simple as that. I decided to use large numbers for you to see that it's not that difficult. Okay, so now we are going to look at fractional numbers, numbers that have decimal points. What are we going to do? Let us look at example 1 of such.